Welcome my dear learners for this course on dynamics of machines. In this module 3 we were discussing on governors and gyroscope. So far we have solved 4 numerical problems on Porter governor. Let us continue our discussion on numerical problems on Porter governor. The problem number 5 of our discussion on Porter governor states that the arms of a Porter governor are each 30 centimeters long and are pivoted on the governor axis. Mass of each ball is 2 kg. At the mean speed of 150 rpm, the arm makes 30 degree with the vertical. Determine the central load and the sensitivity of the governor if the sleeve movement is plus or minus 2.5 centimeters. So this is the given problem. If you observe, all the arms are attached to the governor axis and are of same length, that is 30 centimeters. And the mass of the ball is specified, which is 2 kg, and he is asking us to calculate what is the magnitude of central load, dead load. And also we should determine what is the sensitivity of the governor for a sleeve movement of plus or minus 2.5 centimeter. Let us solve this problem. If I list out the data given for problem number 5, we have the arms of a Porter governor are each of 30 centimeter and are pivoted to the axis. So therefore attach the arms to the axis of the governor. Now at the mean position, we know this is radius r. At the mean position we have mean height h, and at the mean position the angle is also specified, which is 30 degree, and the arms are of equal length, which is 30 centimeters, and this is beta. Therefore alpha is equal to beta at the mean position. Mass of each ball is specified, that is small m, which is equal to 2 kg, and the mean speed n is specified, which is 150 rpm, and the arm makes alpha, which is equal to beta, which is equal to 30 degree only at mean position. Now determine the load W and sensitivity. You people already know sensitivity is nothing but range of speed to the average speed or mean speed. Sensitivity for a sleeve movement, so is specified the sleeve movement is plus or minus 2.5 centimeter. So this is the given problem for us. Let us solve this problem. We know the mean speed, we know what is the angle, and we know arm length. So therefore I can determine what is the mean height and mean radius, using which I can find what is the value of W. Correct? That is, if I move for solution, at mean position we know all the values, hence we know that n square is equal to m plus m by 2 into 1 plus q divided by m into 895 by h, where h is in meters. So this is the general formula, neglecting friction, because he has not specified anything about friction. Neither he has specified nor yet he has asked us to determine the friction. So therefore neglect friction and solve the problem. Since alpha is equal to beta, q will be equal to unity. Correct? So since alpha is equal to beta, q will become unity, because q is equal to tan beta by tan alpha. Since both are equal to 30 degrees, q will become 1. So therefore these two will get cancelled. Now coming for h I can determine by using what? I know hypotenuse, I want adjacent side. So that is cos 30 degree. So I can write cos 30 degree is equal to adjacent by hypotenuse 30 centimeter. So hence h will become 30 into cos of 30 degrees. 30 into cos of 30 degrees is nothing but 25.98 centimeters. 25.98 centimeters is what I got for h. Now I can find what is the value of m, that is n is already known, which is 150 rpm at mean position. So therefore 150 square will be equal to, mass of each ball is 2 kg. I want to calculate what is the value of m into 1 plus 1 divided by 2. This will get cancelled. Divided by m is 2 kg given into 895 by h. H should be in meters. Very important. In meters it is 0.2598. So therefore mass of center load is equal to 150 square into 2 into 0.2598. This must be equal to 2 plus alpha x into 895. If I solve, I will get the value of mass as 11.063 kgs. Hence sleeve weight or dead weight is equal to capital M into acceleration due to gravity. This answer into 9.81, which is nothing but 108.52 newtons. 108.52 newtons is the central load. So we have calculated what is the central load. Now we have to determine what is the sensitivity. I want individual speeds. Speed at minimum radius of rotation, speed at maximum radius of rotation. If I calculate both speed at minimum radius of rotation and speed at maximum radius of rotation, I can find what is the range of speed, and also I can find what is the average speed. The ratio of means range of speed to the average speed will give us sensitivity. Let us calculate what is the value of n1 and n2 by using sleeve movement. He has given sleeve movement as plus or minus 2.5 centimeters. So if I draw this, that is for minimum speed. If I draw for minimum speed, what I am going to get? If I draw for minimum speed, I am going to get like this. So h will be maximum, right? Because the radius of rotation will be minimum. Balls will move towards the axis of rotation for minimum speed position. So thereby the h is higher than mean h. So h1 is higher than mean h. So this is what I will get, h1. h1 is what I will get, and this is r1. From center to center it is r1 radius. Now this is alpha and this is beta, and this length is known, which is 0.3 meters. Whereas for maximum speed, what happens? For maximum speed, if you consider, h will be minimum, whereas radius of rotation is maximum. This you people know, because for maximum speed the sleeve will move up and h will be smallest. So therefore h2 is less than h, and also h2 is less than h1, h2. So this is alpha, this is beta. Arm length remains same, 0.3 meters, and this length is what? R2 for maximum speed. Correct. Now if you carefully observe, for minimum speed he has given the sleeve movement as plus or minus 2.5 centimeters. So therefore for minimum speed, if I write between the mean position and the minimum speed position, the sleeve lift will become what? That is fall, because at the bottom position it is nothing but the general formula of lift, that is 2 times, here h1 is greater than h. h1 is greater than h. We know that sleeve lift formula is nothing but 2 times h1 minus h2, that is between minimum and maximum position. Here the sleeve movement is given with reference to mean position. With reference to mean position, fall is 2.5 centimeters, rise is 2.5 centimeters. That is what sleeve movement stands for. From the mean position, fall is 2.5 centimeters, rise is 2.5 centimeters. Fall means minimum speed, rise means maximum speed. So from the mean position, plus 2.5 minus 2.5. Minimum speed, maximum speed. That is what he has specified here. We know general formula for lift, that is fall as well as for rise. For rise, it is also measured with reference to mean position. It is plus 2.5, right? So therefore always here h is greater than h2. H is greater than h2. You can see here. So highest is h1, next comes h, and least is h2. This is mean position, minimum position, maximum position. Now we know all the values. This is 2.5 centimeters, that is 0.025 must be equal to 2 times h1 is unknown, whereas mean height h calculated, which is 25.98, that is 0.2598. Here we know lift or rise is 0.025, which is equal to 2 times h is known, h is 0.2598 minus h2. So therefore if I calculate, I will get the value of h1 and h2. How much is h1? 0.025 divided by 2 plus 0.2598, which is nothing but h1 is turning out to be 0.2723 meters. This is the value of h1, and h2 is turning out to be 0.2598 minus 0.025 by 2, which is nothing but 0.2473 meters. Hope you have followed the calculation. We know the general expression for sleeve lift. Lift is equal to 2 times difference in height, that is between the minimum and maximum position. Lift is equal to 2 into h1 minus h2 is the general expression. But here he has specified the sleeve moment with reference to mean position. So from the mean position there is a fall of 2.5 centimeter and also there is a rise of 2.5 centimeter. So we know the formula for sleeve moment, that is 2 times delta h. So from the mean position there is a fall of 2.5 centimeters. This is what I have taken. From the mean position there is a rise of 2.5 centimeter. This is what I have taken. Now solve for h1 and h2. Since we have calculated h1 and h2, now I can easily find what is the value of n1 and n2. So use the formula n square is equal to m plus m by m into 895 by h is the formula. So therefore I will get the value of n1 and n2. Now if I substitute h1, I will get n1, that is m is 2 kg, 2 plus capital M is 11.063 divided by 2 into 895 by h1. h1 is 0.2723. So I got the value of n square. Root of answer will give us n1. So n1 is turning out to be 146.519 rpm. So similarly if I substitute h2, I will get n2. So n2 will become, m is 2 kg, capital M is 11.063 divided by 2 whole multiplied by 895 by h2. h2 is 0.2473. I got the value of n2 square. Root of answer will give us n2. n2 is turning out to be 153.7467 rpm. You can check out the answer. n1 is the minimum speed, 146. n is the average speed or mean speed, mean position, that is 150, higher than n1, and n2 is maximum, which is higher than n, 154 rpm. So the answer seems to be correct. Now I can find what is the range of speed. Range of speed is equal to n2 minus n1, which will become 153.7467 minus 146.519, which is 7.23 rpm, and now sensitivity will be range of speed by average speed, n1 plus n2 by 2. So we know the range of speed into 2 divided by n1 plus n2 divided by n1 plus n2, 146.519 plus 143.7467, which is equal to 0.481, 0.0481, which is nothing but 4.8%. So the sensitivity of the governor is 4.8% and the range of speed is 7.23 rpm. So it is 4.8% is the sensitivity for this problem. Let me pause this video for a while so that you people can copy it down. Later we will address the problem number 6. Now moving ahead, the problem number 6 states that all the arms of a Porter governor are 178 mm long and are hinged at a distance of 38 millimeters from the axis of rotation. The mass of each ball is 1.15 kg and the mass of sleeve is 20 kg. The governor sleeve begins to rise at 280 rpm when the links are at an angle of 30 degree to the vertical. Assuming the friction force to be constant, determine the minimum and maximum speed of rotation when the inclination of the arms to the vertical is 45 degrees. He is asking us to take the friction force constant and determine what is the minimum and maximum speed when the inclination to the vertical is 45 degrees is what he is asking. But he has not specified what is the value of friction force. First let us calculate the value of friction force, take it as constant and determine what is the minimum and maximum speed for 45 degree inclination of the arms with reference to vertical. Come, let us solve problem number 6. If I list out the data given, we have a Porter governor, mark the axis of rotation, and all the arms are hinged at a distance of 38 mm. So we have an eccentricity of 38 mm. We have an eccentricity of 38 mm, wherein which they have hinged to the axis at a distance of 38 millimeters. Right, and we know the value of alpha and beta. This is what he has specified. Now I should extend it back to intersect it to the vertical. Now extend it back to intersect it to the vertical and call it as O. And this is what the height h is. This is what the height h, and this is what the radius of rotation r. Correct? Let us call it as A, B, and this point as C. Here I will call it as D. Now we know the eccentricity. The eccentricity is 38 mm and all the arms are 178 mm long. 178 mm long. All the arms are 178 mm long. That is AB is equal to 178. BD is also equal to 178. Mass of each ball is specified, small m is equal to 1.15 kgs, and mass of the sleeve, capital M, is also specified, which is 20 kg. Now the speed n is specified, that is 280 rpm. When the links are at an angle of 30 degree with reference to vertical, he has given alpha is equal to beta at 30 degrees. Find the value of friction force. Assuming this friction force to be constant, find n1 and n2 for alpha is equal to beta, which is 45 degrees. So this is what he has specified. Come, let us find what is the friction force first. If I move for solution, first I should determine what is the value of R and H. Correct? We know only this angle alpha, which is 30 degree, and we know 178 is the arm length. So therefore, if I extend it forward and cut it, let me call it as E. So from triangle ABE, what I can write? From triangle ABE, sin alpha is equal to opposite side. Opposite side is BE. BE is how much? BC minus EC. That is R, overall R minus 38 mm. That is R minus 38 mm divided by 178. So therefore I will get what is the radius of rotation. How much is the radius of rotation? The radius of rotation will become sine of 30 degrees must be equal to alpha x minus 38 divided by 178. If I solve, I will get the value of R as 127 millimeters. Now if this is alpha, this is also alpha. If that is alpha, this must be equal to alpha only, right? So now use this alpha and find what is the value of H. That is from triangle OBC. From triangle OBC, I can write cos alpha. Cos alpha is equal to adjacent side is H divided by hypotenuse is, I don't know what is hypotenuse, correct? Because I don't know what is OB, I know only AB. So let me go with tan alpha. Tan alpha is equal to opposite by adjacent. Opposite is R, adjacent is H. Hence H will become, R is 127 divided by tan of 30 degrees. So H is 219.97 millimeters. We got the value of H. Now I can find what is the value of friction force. That is, we know N square is equal to, by considering friction, N square is equal to mg plus or minus F whole divided by 2 into 1 plus Q divided by mg into 895 by H. Correct? Now we know the value of Q. Q is equal to unity because alpha is equal to beta. So Q is equal to tan beta by tan alpha, which is equal to 1 because beta and alpha are equal to 30 degrees. So these two and this one will get cancelled. This and this I cancel off. Now if I get the formula for F, what I will get? So plus or minus F will become N square into mg into H. That is N square into mgh, N square into mgh divided by 895 minus mg minus capital Mg is the value of plus or minus F. Correct? Check out once again whether I simplified it properly or not. N square mgh divided by 895 minus mg minus capital Mg. Correct. Now if I solve, I will get the frictional force plus or minus F as N square is 280 square into m, mass of the ball is 1.15, g is 9.81 into h should be in meters. Substitute h in meters. H should be in meters. So substitute H in meters. In meters it will be 0.21997 divided by 895 minus mg, that is 1.15 into 9.81 minus capital mg. Capital M is 20 into 9.81. So plus or minus F will become 9.9 newtons. Plus or minus F is turning out to be 9.9 newtons. Now use this to find the value of N1 and N2 when alpha and beta is equal to 45 degrees. That is now when alpha and beta are equal to 45 degrees, I should solve for the same to find the value of H, because H differs when alpha and beta is equal to 45 degrees. Let us calculate the value of H when alpha and beta is equal to 45 degree. When alpha is equal to beta is equal to 45 degrees. What is the value of H is the question. So from the same analysis, from triangle ABE, I can write sine of 45 degrees is equal to R minus 38 by 178. Hence I will get the new value of R, that is sine of 45 is equal to alpha x minus 38 divided by 178. If I solve, I will get the radius of rotation as 163.865. Now from triangle OBC, tan alpha is equal to R by H. So here alpha is how much? 45 degrees. Hence H will become how much? Tan 45 is equal to R is 163.865 divided by alpha x. If I solve, I will get the value of H as 163.865. Yes, it is correct because tan 45 degree is unity. Hence H is 0.163.865 meters. 0.163.865 meters. Now first one, at minimum speed. At minimum speed, friction force should become negative. So therefore N1 square will become what? N1 square is equal to mg plus capital MG minus F by 2 into 1 plus Q divided by mg into 895 by H. So therefore how much is N1? We know all the values, that is mg. So these two and this will get cancelled because Q is equal to 1 because alpha is equal to beta. Now mg is 1.15 into 9.81 plus capital MG. Capital MG is 20 into 9.81 minus 9.9 is the friction force. 9.9 divided by mg, 1.15 into 9.81. Whole of this should be multiplied by 895 by, let me call it as H dash. To avoid confusion, let us call this as H dash. 895 by H dash. H dash. H dash is 0.163.865. I got N1 square. Root of this will gives us N1. N1 is turning out to be 309.28 rpm. Now N2 square will become what? mg plus f by 2 times 1 plus q. This and this will get cancelled because alpha is equal to beta divided by mg into 895 by h dash. Hence N2 for this problem will turning out to be how much? Mg, it is 1.15 into 9.81 into 20, plus mg 20 into 9.81 plus 9.9 divided by 1.15 into 9.81. Whole of this must be multiplied by 895 by h dash, 0.163865. So if I solve, I will get N2 square. Root of answer will become N2, which is 324.41. 324.41 rpm. The maximum speed is 324.41 rpm. Minimum speed is 309.28 rpm when the arms makes an angle of 45 degree with reference to vertical by considering friction force as constant, which is 9.9 newtons for this problem. This is the complete solution for problem number 6 that's solved from this lecture. Thank you all.